From the last video, we did a little bit with elasticity. We figured out that our elastic equation was equal to P divided by 501 minus P. And so this question asks, what would be the maximum revenue for this product that is being demanded? And it turns out, and you'll learn about this more in economics, but it turns out that this is maximized when the elasticity is equal to 1. So to find the elasticity, all we need to do is just set this equation equal to 1. So we got 1 equals P over 501 minus P, like that. Multiply the 501 minus P on both sides. So all I did there was just multiply both sides of the equation by 501 minus P. And we get 501 minus P equals P. Add the P over. We get 501 equals 2P. Divide by 2, divide by 2, and we get our answer, which is 250.5. So the best price for this product for maximum revenue when the elasticity is equal to 1 is 250.5. And again, this comes from the actual demand equation, which you can find by using regressions and doing studies. And if you want to learn more about that, it's really interesting, and I encourage you to take microeconomics, where you will learn more about elasticity. All right, let's do this exact same process for this demand function. Function's a little bit more difficult, but everything is the same in terms of what formulas we use. As a reminder, let's write down what the demand equation is. The demand equation is equal to, the elasticity equation is equal to negative P times d prime of P divided by d of P. That's the equation for elasticity. So let's go ahead and find that equation for this. The answer is going to be the elasticity is equal to negative P times, and then down below, I'm just going to put the actual function. All right, so we're here. I did the negative P and I did the function. Now off to the side, let's do the derivative. So the derivative of this is going to be the quotient rule. You could actually do the power rule if you wanted to, but I'll go ahead and do the quotient rule. It'll be x plus 5 to the 10 on the bottom. Then we have low times the derivative of the high. And notice that that's going to be 0 because the derivative of high is 0. The derivative of a constant 600 is 0. So low times the derivative of the high is going to be 0. Quotient rule says I then have a minus, and then it's high times the derivative of the low. So the derivative of that, the 5 comes out in front. Then it's x plus 5 to the 4 times the derivative of the inside, which would just be 1 from the chain rule. So that is our derivative. And let's go ahead and clean this up a little bit. So I noticed that 4 of these x to the 5s will cancel, which will make that a 6. So I get negative 3,000 on the top and x plus 5 to the 6th on the bottom. Okay? And I put x's in here, but they could very easily be p's. And so that's what we will do. It could be x or p, it doesn't really matter. So let's just put that in here, negative 3,000 over p plus 5 to the 6th, and we'll make this a p2. Okay, so we've got a lot going on. Let's clean this up a little bit more. The elasticity will be 2 negatives make a positive, so this will be 3,000 p over p plus 5 to the 6th. And again, hopefully I didn't confuse you with that x and p thing. Everything's fine if it's all p's. Now I'm going to do copy dot flip to multiply this times the bottom fraction. So if we do the bottom fraction, copy dot flip, this is all the numerator. Copy dot flip the bottom one, it'll be 600 on the bottom and p plus 5 to the 5 on the top. You'll notice that 600 cancels with 3,000, which will be 5. And 6 of these p's will, or 5 of the p's will cancel. So we end up with just 5p on the top. That's all we're left with on the top is 5p, and on the bottom we just have p plus 5. And that is actually the answer. So I know this step is a little bit tricky. I just did 2 negatives make a positive. The p I put up with the 3,000. Now that was one fraction, and so we could do copy dot flip, flip the second fraction, and then a bunch of stuff cancels and it works itself out. Okay, so that's how we do that first part. What about a price of 7? If we put in a price of 7, we get 35 on the top because 5 times 7 is 35. We put 7 on the bottom, it's 7 plus 5 is 12. And so you can see that at that price we are elastic. Because our elasticity is, so at a price of 7, our elasticity is greater than 1, so we are elastic at that price. Let's find out when this is maximized. When revenue is maximized, the elasticity is equal to 1. So all I have to do is set the equation equal to 1, and then we'll solve it. So multiply the p plus 5 over. We get p plus 5 equals 5p. Subtract p. We get 5 equals 4p. Divide by 4, divide by 4. P equals 1.25, or 5 divided by 4. That price is when we will have the maximum revenue because we have a unit elasticity. I know I went through that problem kind of quickly. Hopefully it makes sense. If it does not, please send me an email or reach out to me and I'll be happy to answer your questions. I wasn't able to get to everything in Chapter 3, but hopefully this will be enough of a base for you to complete the parts that I couldn't get to. Thank you so much, and I will see you next time.